The purpose of this video is to give you some traction in solving this WeBWorK problem, sum to product and product to sum question bank, problem number 5. Let's begin by looking at the product to sum formulas in the special case when alpha equals beta, and we'll call that x. So this one here would become sine x times sine x, so sine squared x. And then over here, x minus x, alpha minus beta, that would be 0. Cosine of 0 is 1. And over here, you're going to have alpha plus beta, or x plus x, that would be 2x. So in the special case of alpha equals beta equals x, these first two product to sum formulas reduce to these two equations right here. Now let's look at sine to the fourth x. That's going to be just sine squared x times sine squared x. And what we're going to do is we're going to take this expression up here and replace sine squared x with that in each case. So here I've made that replacement, replacing sine squared x with 1/2 minus 1/2 cosine 2x. Comes from up here. Next, I'm going to multiply this out, or FOIL it, and I'll have a half times a half, and then that's my first term, and then my inner term would be a half times minus a half cosine 2x. Outer term is the same thing. Then the last is minus minus, it's plus a half times a half, a fourth cosine 2x times cosine 2x. So we multiply that out to get these four terms, like a half times a half and all that. Notice that these terms here are the same, so I can combine them. So I combine these two terms into this single term. The 1/2 comes from the fact that 1/4 plus 1/4 is 1/2. So let me put that all up here. Recapping, sine to the fourth x then is going to be this expression right here. Right, sine to the fourth x in that expression. I'll move this equation up here. Now here's the next step. Look at this term. It's cosine 2x times cosine 2x. It's a product. So we're going to be able to use this formula right here to break it up into a sum of two things. So we need to work with cosine squared of 2x. So I come up here and I replace x by 2x, right? So cosine squared of 2x. And the connection here is that this angle and this angle are related by the fact that this second one is double that one. So in my case, I'm starting with 2x, so this angle over here should be the double, which is 4x. Other than that, everything else is the same. So what I'm doing is in this formula is I'm replacing x with 2x. Okay, so let's get this out of the way. Back to this, we're going to replace cosine squared 2x with this over here. So you see I've replaced cosine squared of 2x with this over here, right there. Notice I can combine the 1/8 plus 1/4 into 3/8. So you see what we've done is we've taken a power of sine x, the fourth power, and written it as a sum of cosines. Sure, the cosines have different frequencies, but still it's a sum of cosines. For example, it's kind of a lot of work, but sine to the 8th of x, so that's when n equals 8, turns out to be this sum of cosines, cosine 2x, 4x, 6x, 8x. So it's a sum of cosines, different frequencies for sure, but it's a sum of cosines. Another example, this one here is sine to the 9th. So it's a sum and differences of sine x, sine 3x, sine 5x, sine 7x, and sine 9x. So the big picture here is that by using the product to sum formulas, you can take any power of sine, or any power of cosine, or something kind of mixed like a power of sine times the power of cosine, like sine cubed times cosine to the 8th. And by patient working with the product to sum formulas, you can reduce any one of these types of forms to a sum of sines and cosines with different frequencies. My cat Inky says that's cool, but seriously, it's time to feed me.